guys, we're starting. This is pretty easy. We're going to pay attention now. We're going to do math. We're going to close your computers. Okay? This is called a three-dimensional coordinate system. Okay? So this particular orientation of it is called a right-hand three-dimensional system, because if I were to put one finger this way and one finger this way and my thumb up this way or something like that, this would be my big finger, my big finger, my middle finger, and my up finger would look kind of like that. If we're a left-handed coordinate system, then it would look more like that. So this would be the positive. How would that look? This would be the x, that would be the y, and this is the z. But in this case, and most of the time, they will use a three-dimensional or a right-handed coordinate system. So this is the positive x-axis, this is the positive y-axis, and this is the positive z. Okay? If you have negative coordinates, then you go down. Okay? And if you have negative y-coordinates, you go backwards. And if you have negative x coordinates, then you go this way. So if I want to get to the point negative 1, 3, 2, okay, I would start at the origin just like I do, and I'd go back 1, I'd go over 3 this way, and then I would go up 2. So it's kind of hard to tell where exactly that is, but it's kind of on a vector that goes from here. So I'm going back 1, then what? Excuse me, I'm going back 1 this way, then I'm going out 3, and then I'm going up 2. So that's one way I could get there. Okay? This point for negative 2, 5, I go out 4, 1, 2, 3, 4, and then I would go back 2, 1, 2, and up 5, wherever that happens to be. It's kind of hard to tell because you're kind of in space, you know. So say I were to connect these 2 points, A and B, I think it's easier to see if you draw kind of lines to them. You can use the distance formula, just like you remember the distance formula from 2 dimensions. It's just a Pythagorean theorem in 3D. So if I want to find the distance, let's not put arrows. If I want to find the distance from A to B, I could use that distance formula here. So if I want to find in 3D the distance between those 2 points, I just plug and chug right into here. So I would go negative 1, well, you go x2 minus x1. So that'd be 4 minus negative 1 squared plus negative 2 minus 3 squared plus, did I do this right? Negative 2 minus 3 plus 5 minus 2 squared, which gives you 25 plus 25 plus 25. Plus 9, right? Plus 9. Did I do that right? And I take the square root of that, okay? And that is equal to the distance between A and B. So AB, which means the distance between points A and B, is equal to the square root of 59. So in that case, you would take that, and that's the square root of 59 from here to here. And basically where that comes from is just doing the Pythagorean theorem twice. Okay? Then we also have the midpoint formula in 3D. Midpoint formula, just like you have the midpoint formula for x's and y's, you can have the midpoint formula for x, y's, and z's. And so the way you do that is just by plugging into x1 plus x2 divided by 2, comma y1 plus y2 divided by 2, comma z1 plus z2 divided by 2. So if I want to find the midpoint of AB, okay, and I don't know if you remember from geometry, but if you put a bar on top of it, that means this segment. If you don't put a bar on the top of it, like over here, that's a quantity, like a length, okay? So when I take the bar out, that means the distance from, okay? And so the midpoint in this case is just x1 plus x2, which is -1 plus 4, -1, right? -1 plus 4 divided by 2, comma, 3 plus -2, 3 plus -2 divided by 2, comma, 2 plus 5, 2 plus 5 divided by 2. And if I do that, I get 1.5, right? 1.5. 3 minus 2 is 1 divided by 2 gives you 0.5 or 1/2, and then 3.5. So in other words, if I were to come out 1.5, out there, and then move over this way a little bit, 0.5, and go up 3.5, look, it looks like that looks like about the midpoint, okay? And so this would be the mid, we'll call it M, and that would mean that that piece from there would be equivalent to there. That looks pretty cool in 3D. All right, so anyway, that's the midpoint formula, that's the distance formula. Okay, now we're going to talk about equation of a sphere. Ready? Sure. The equation of a sphere, everyone got that? Can I move on?
Yeah.
It's quick. So the equation of a sphere is a sphere. It's just like the equation of a circle in 2 dimensions, but it's x minus h squared plus y minus k squared plus, and they use z minus j squared equals r squared. Okay? So that would be the equations here where h, k, j would be the center, and r would be the radius. R equals the radius. And so they might say, draw a graph in graph equation of a sphere. Graph the sphere. Graph the sphere, and x minus 2 squared plus y minus 4 squared, y minus 4 squared plus z minus 3 squared equals 9. Could you do that? Sure you could. So first what I would do is make a, we'll put arrows on the end of my axes. We'll put arrows going one way. We'll make them solid. And then we'll make them green. So I'm going to go this way. I'm going to go that way. I'm going to go this way. Isn't that cool? And, oh, by the way, this is called, so if this is z, this is y, and this is x. This plane over here, this is called, so from here to here, right, from this plane and going back this way, go back this way and stuff, okay, that would be called the, oh, that should be a x, not a z. This is the xz plane. XZ plane. And this plane down here, what do you think that's called? This is the XY plane down here. And this plane over here is the ZY plane. This one that's kind of going across this way, right? That's the ZY plane. ZY plane. And I guess I could kind of get you in knowing that these are all the positive planes, right? And they go back, like this one goes back this way. This one goes back. Oh, look, I'm doing pretty good. This one goes back this way. And then, so if I want to sketch this sphere in here, I'm going to go out 2 on the x. Out 2. And then I'm going to go over 4 on the y, because So let's kind of 1, 2, 3, 4. So we're going to come this way across here to about 4. And then I'm going to go up 3 units. So this would be kind of the center of my sphere. And then I would take my tools and I would look for a sphere. Is there a sphere on here? There's a circle. I could fake it, okay? So maybe this is where my circle starts, and then I could be very clever and I can do a little like okay, so there would be your center of your sphere, and then it would be hanging out in space like that. Isn't that cool?
That's awesome.
Thank you, thank you. Good. It's fun to do. It's fun to try this. Okay, done with that. Then you have problems which we've done with conics, and you should be pretty good at this by now. It says you'll have something like complete the square, complete the square to put the circle in standard form. Circle in standard form, and then graph it, maybe find the radius, find the center, and all that kind of stuff. So if you have something that looks like this, which you will, x squared plus y squared plus z squared minus 2x plus 6y minus 4z minus 2 equals 0. Could you do that problem? Complete the square? What would I do first?
Get all your x, y, and z's together.
Nice. Gather up your x terms, okay? X squared minus 2x, right? X squared minus 2x. Get your y squared with your plus 6y. Get your z squared with your minus 4z. And then bring the 2 over onto that side. And then just complete the square like we've been doing for all your other stuff. X minus half of that squared plus y plus half of that squared plus z minus half of that squared equals 2 plus what?
4 plus 9 plus 1.
2 plus 4 plus 9 plus 1, or 2 plus 1 plus 9 plus 4, right? Any questions on that? Which equals 16, right? And so this is a sphere with the center at 1, negative 3, 2. Right? There's a center. And there's and the radius is what? 4. Right? Easy enough? Yes? And a sphere in space. So if I have my sphere, there must be better pictures. I know they watch this. Watch me go here. Gallery. Loading the gallery. I'm loading the gallery here. In golf matches, they have a loaded gallery sometimes.
What is the gallery? Is that like the crowd?
Yeah, the crowd. They usually drink too much, so there's a loaded gallery. But here I'm just loading the gallery. Okay, so geometry. Where's the 3D shapes? Oh, just go back up. Back 3D figures. Okay, go. Oh, look. I have a sphere. I know I have a sphere. That's a sphere. That's not very exciting. So if I were to get a new page, here's a sphere. Ooh, look at that. All right, good. And so here's a sphere, and this is called it's called a surface. A sphere is called a surface. A surface in space. So in other words, if in that last, so say I have a sphere with x minus 2 squared plus y plus 5 squared plus, I don't know, z minus 1 squared equals 36, right? Where it's called a surface because the interior points aren't part of this sphere. It's just the points all on the outside, because the definition of a sphere is just all the points that are equidistant from a given point of the center. So it's a surface because it doesn't include any, it's not a solid, right? It's just the surface of the sphere. All right? And that's called a surface in space. Okay? And then, so if, what was I going to say? So any point on this surface should satisfy this equation. So for example, you could plug in a point like 5 here and 0 here. Maybe I plug in -5. -5, what would that be so far? That'd be 16. So you could find out what x is when given the other 2 points. See, so what's x? Find x when y is -5 and z is 5. And you can plug those in, find x. We go x minus 2 squared equals 0, or plus 0, right? Plus 0 plus 16 equals 36, right? So x minus 2 squared equals 20. And then you can take the square root of both sides, so you get x minus 2 equals plus or minus the square root of 20. So x equals 2 plus or minus the square root of 20. So in other words, I would have one point that is 2 plus the square root of 20 in the x direction. Oh, I don't know how to. And then one that's 2 minus the square root of 20 in the x direction. And then y would be -5, and then z would be 5. It's hard to see when I'm not in the coordinate plane. Okay? Next thing, yeah, you're going to see is called a, where'd my gallery go?
Did you always get 2 answers because it's a sphere?
Yeah, unless it's right on one of the axes.
But even
Yeah, then you'd have a top one and a bottom. Yeah. So yeah, I think so. Yeah, you would because you're taking the square root. Yep. Okay, and then you have something called a trace. The intersection. And I didn't know this before, but I guess this is used a lot when you get to Calc 3 and stuff, or we call it Calc 2 here, but Calc 3 here, but in college it's called Calc, like calculus in 3 dimensions. The intersection of a surface, with one of the coordinate planes, one of the for a plane parallel to a coordinate plane. Is called a trace. Okay, and so and I'll show you what I mean. So find the trace. Find the trace of the sphere given by x minus 4 squared, x minus 4 squared plus y plus 3 squared plus z minus 1 squared equals 25, and the XZ plane. Okay? So it's kind of nice to visualize what this means. So I'm going to try to draw this. All right? There's my line tool. So what you have here's something going like this, something going like this, something going like this. So the center of the sphere is at out 4, back 3, up 1. You guys get that? Okay, out, positive 4, negative 3, up 1. And then, I don't know if that's where it is, but kind of, we're estimating. What's the radius of this sphere? 5. So I'm going to kind of draw in a sphere right here, try to draw it. And then I'm going to kind of draw in, try to make it look 3D. Like this. So here this sphere. Yeah, well, it's kind of, oh, if the radius is at 5, is it? It should? Yeah, I guess you're right, it should. Well, it's kind of hard to, yeah. Circle should have been bigger, Tracy said. She's right. So in any case, the way you do that, the XZ plane, this is the XZ plane over here. So this thing, I'm going to cut this with the XZ plane. What's going to happen if I slice that, if I stick that through my slicer? What am I going to get? I'm going to get a circle. Do you guys understand that? Okay? It's like if you take a big cheese ball and you put it on a cheese slicer, you're going to get a circle, right? And what's, if it's in the XZ plane, what's the y coordinate of this, of the x? If for any point in the XZ plane, what's the y coordinate? 0, right? So the way I can figure out what that is by plugging in 0 goes in there for y, you see? And then you get x minus 4 squared plus 3 squared, right? Because 0 plus 3 makes 3. Plus z minus 1 squared. Z minus 1 squared equals 25. And you do some math, which gives you x minus 4 squared plus 9 plus z minus 1 squared. I didn't need to do that stuff. And you get x minus 4 squared plus z minus 1 squared equals 16. So what is this? It's a circle that has x's and z's but no y's, right? So it's a circle somewhere and it has a radius of 4, right? So if I were to draw it, it's kind of sideways, right? It would be a cut. You'd be cutting this thing like that. So you get this slice in here that has a radius of 4. See that?
Wouldn't the circle's radius,
What?
wouldn't the circle's radius be the same as the sphere's radius?
No, because if you put like this on your cheese slicer, right, you get some, here you get a big circle.
I see what you mean.
Yeah, you only get, like, the closer you are
I see.
over this way, you get, right? If it goes through the center, that's called a great circle. But this is not a great circle, it's just a so-so circle. You know? But so it's got a radius of 4, so it'd be a slice run over like that. Okay? And that's what they mean by the trace. Okay? And that's all she wrote, boys and girls. I think I tell you everything. It's really easy. Okay? And so your homework is on my Cutting Edge website. And we haven't gotten very far with any of this stuff, but just to today's, one day at a time here. And you guys assignments, hopefully it'll show up. Chapter 10, there it is. Page 716. Want to make it bigger?
Took an AP test today.
Oh, it's up on the board. It's on the board. What happened? There it is.
Color.
What?
I like the color.
Yes.
I like that too, it's kind of a teal. Yeah. So this means every other even, this means every other odd. Okay, so that's not any. Okay, I'm gonna quit here.
Giant pieces of
File, pause.